Hello all, welcome back to my YouTube channel all about VLSI. From this video, we are going to start with PCI protocol series, where first of all we are going to understand about ISA and EISA buses. First, let's try to understand what is this bus architecture, why we are going to discuss about PCI, like what is before PCI and all. We will try to understand first, right? So if you are watching this particular channel without subscribing, please make sure that you have subscribed to this particular channel for more such protocols. Now, so first of all, let us try to understand what is this ISA and what is this EISA buses. Okay. Now, first of all, before going to start this, what do you mean by bus? So bus is nothing but bundle of signals, right? So you're going to collect a group of signals and you're going to say it as a bus. And ISA stands for Industry Standard Architecture, and EISA stands for Extended Industry Standard Architecture for buses. Okay. So how to arrange a particular group of signals you're going to uh, basically describe in the case of your ISA and EISA buses. Now, what we are going to cover in this particular session is we are going to discuss about bus fundamentals, like what a computer bus is and why ISA or EISA still matters conceptually, and what do you mean by ISA bus. And we are going to discuss about 8-bit XT and 16-bit AT generations, architecture and signal lines. And next, we are going to discuss about EISA bus, where we are going to discuss how it is backward compatible and why we need a 32-bit bus and how it is going to work and all. And we are going to compare both IASA and EISA, and we are going to end this particular session. So this is what we are going to cover in this particular session. Now, what is a computer bus architecture? See, every particular computer, we are going to have some kind of CPU, processor, memory, and peripheral devices, everything we are going to. And if I want to communicate, or if I want to transfer data, let's say from CPU to memory, or any particular external card to my CPU, it may be a graphics card, or it may be, other external sound card or Ethernet controller card, any particular external device. If I want to communicate it with my CPU, I'm going to not have dedicated buses for each and every particular device. No, every particular device is going to share a common bus. If you are going to have for each particular device, for each particular external device, you are going to have dedicated buses for everything, then you're going to have a lot of area, right? You're going to occupy a lot of area. So that's the reason I'm going to use a shared bus. Okay, so every particular device, so it may be a memory controller, or it may be a disk card, or it may be external memory, or it may be a sound card or graphics card, everything is going to share a common bus. Okay. Now, this is what it is written over here. So every computer, the processor, memory, and peripheral devices need a common electrical highway for exchanging data, address, and control signals. And this highway is called as a bus. And a bus, as I've said you previously, that is it is nothing but a set of parallel wires shared by multiple components along with a defined protocol. And this protocol is basically describing us how each particular component is going to use the wire. And since we are sharing this particular bus with every component, and let's say if every component is going to have its own timing and all, you're going to enter into chaos, right? So that's the reason we are going to have some specific set of protocols which is going to describe us when to use a bus, how to use a particular bus. Okay. Now, first of all, we need to understand something known as the type of buses. So basically, buses are classified on the basis of how they are going to connect or what they are going to connect. See, we are going to have something known as internal or CPU bus, where my processor is going to connect with my cache and the registers. Okay, so if your processor is going to use its internal bus for connecting to the registers, and I'm going to use another kind of bus which is known as memory bus, which is going to have the connection from the CPU to the memory. And another is expansion bus or input output bus, where I'm going to basically connect my external buses with my memory. Okay, this is nothing but my expansion buses. So I have basically three kind of buses. One is CPU bus, use it for connecting my CPU with my internal registers, and another is memory bus for connecting my CPU to main memory, and third is expansion or IO bus for connecting my external devices to my processor. Now, so this is what I was saying about. let's say if you have a particular processor and if you want to connect external devices, you're going to connect it via this particular slots. And what do I mean by this slot and how we are going to connect it on all, we're going to discuss. Okay. Now, first of all, let's try to understand this particular ISA, which stands for Industry Standard Architecture. And this particular ISA was introduced by IBM for the original PC, and ISA became de facto expansion bus standard once the rest of the industry copied the design and the name came later. Now, let's say suppose if I want to connect multiple external cards like disk controller or graphics card or a network adapter and everything, and if I want to communicate it with my particular processor, then how I'm going to connect them externally? I'm going to connect them externally via this common slots or the shared bus. So here I'm going to insert whatever the cards I want to insert, and these cards are going to share a common bus. And I was using previously we were using ISA, industry standard ISA bus. So it was never formally engineered top to down, and it was given into a standard by adoption and gave the IBM PC its defining trait, easy hardware expandability. And it was introduced in year 1981. And the width of this bus, the ISA bus, was only 8-bit width, and later it was extended to 16-bit width, and it was having basically 62 connector pins. So this was about your ISA, and this ISA is nothing but it's a bus architecture, that's it. And it is going to tell us how to connect multiple external components to communicate with our processor. That is nothing but my ISA. Now, there are basically two generations of ISA. One is 8-bit ISA and another is 16-bit ISA. Now, 8-bit ISA was introduced by IBM in 1981, and it is 8-bit wide data path, and it is going to have the clock frequency around 4.77 megahertz, and it used a single 62 contact edge connector, and it was having addresses up to 1 MB. That means we use it to have 20 address lines. Whereas in the case of 16-bit ISA, it was introduced by IBM in 1984, and it adds a 36 contact extension segments and total 98 pins and 16-bit data path, and address lines are extended up to 16 megabits. That means we total have 24 address pins, and it is standardized at 8 megahertz. And it is also fully backward compatible with 8-bit cards. It also supports 8-bit ISA as well as 16-bit ISA. Now, what do I mean by this 8-bit, or what do I mean by this 16-bit? You can see this particular card, which is known as a network card. And this is nothing but my pins, ISA pins. Okay. Now, this card is basically inserted in the slots. You have the slots, right? You're going to insert it into this particular slots. And here, 8 bits refer to 8 bits transferred in one bus cycle. So, in a cycle, you're going to transmit 8 particular bits. And that is what? So, 8-bit bus means the device transfer 8 bits of data at a time between the Ethernet controller and the host system. And how you're going to, and this is how you're going to, your data pins are going to look like. You're going to have total 8 pins, and remaining pins are basically used for address. Okay. Now, how we are going to identify it? By just looking it into this particular pins, and you're going to have a few pins dedicated for your data and few pins are dedicated for your address. Okay. Now, how you're going to have this ISA connecting layout. So basically, 16-bit 80 slot is nothing but combination of 8-bit as well as 16-bit. So you're going to have a 16-bit slot and a so you're going to have a 8-bit slot as well as a 16-bit extension. So you're going to have a gap between it. So how to identify it? And you're going to plug it into an expansion card. So it is going to look like this. So this is 8 bits and this is for 16-bit. So this is nothing but my 16-bit 80 slot. Now, so how your ISA is going to look like? So CPU is not never going to talk with the external cards directly. What is going to have is we are going to have something known as bus controller. Okay. So this particular bus controller is going to translate our CPU cycles into ISA cycles, and it is going to manage our interrupt and DMA arbitration. So you can see these are all my external cards which I'm going to have. It may be a 8-bit XT or it may be a 16-bit XT, and here have free slots left out. Okay, so what I'm going to do in the picture I've shown you, right? So using this particular pins, these pins are inserted into this particular slots. We are going to insert this particular pins into this particular slots, and we are going to communicate with my processor. And how the processor is going to communicate with this particular external devices which were inserted into the slots, we were going to use something known as bus controller. And all these particular slots are connected to a shared bus. See, I was not going to have any separate buses over here. I'm having a shared bus, and using this particular shared bus only, my all the external devices are going to communicate with my processor via the bus controller. So bus controller is going to basically control it. Okay. Now, so in our ISA, we are going to have something known as address bus, data bus, and interrupt request, and DMA request and acknowledgement and control lines. Okay. So the address and data lines are so on. Okay. Now, the strength of this particular ISA buses is it is extremely simple and inexpensive to implement, and it has huge install base, nearly universal compatibility, and it is easy for hobbyistics and small makers to design cards for, and it is well documented after decades of widespread use. But coming to limitations, its maximum data width is 16 bits itself. So for one cycle, you're going basically transfer 16 bits itself, and bus speed is fixed near 8 megahertz, and no bus mastering in the original design, and you need to configure it using manual jumper. Okay, now this is the limitations of our ISA. Later, we have introduced it. So we got something known as EISA, which is nothing but Extended Industry Standard Architecture. So by 1980s, we got this particular extended industry standard architecture, which supported 32-bit CPUs. Okay, so in 1988, nine PC manufacturers, the Gang of Nine, which includes this particular companies, created EISA as an open standard 32-bit alternative to IBM's proprietary microchannel architecture. So this was about our EISA. Now, what is EISA supports? So basically, EISA also supports backward compatibility. That means it also supports ISA also. So ordinary ISA cards have shorter pins. So ISA pins use it to have shorter pins. You can see. So this particular ISA pins have shorter pins. And what is happening with this? So ISA pins have shorter pins. They only reach shallow row and work exactly as a normal ISA slot. Now, whereas EISA slot are longer, and EISA have longer pins, and they reach deeper recessed row and unlocking extra address, data, and bus master signals. So if I'm going to use a ISA card, it is going to enter into a particular extent of a slot. But in the case of my EASA, it has longer pins, and it is going to enter into more deeper slot of that particular EASA. And due to this, we can use a particular concepts of burst control, burst master arbitration, and these are reached only by longer pins of EASA cards. Let's say suppose if you have a EISA slot present with you, and you can also use ISA pin, okay, and also you can use EISA pin. Now, this is what I was talking about. So you have longer pins and you have EISA pins which can enter into longer you can enter into longer EISA slots. Okay, this is what EISA helps us. And your EISA aware bus master cards and ordinary ISA cards coexist in a same physical bus, and it is coordinated by a more capable EISA bus controller. And EISA bus controller can basically perform bus arbitration, bus master handoff, burst mode, logic auto configuration. But ISA was a simple architecture, whereas EISA can control all these particular things, and we can have all the particular peripherals connected to this. So we have bus mastering, burst mode, and auto configuration in the case of my EISA bus configuration. So basically, in the case of my plain ISA, a card can ask CPU DMA controller to move data one step at a time. And bus mastering, an EISA card asks for a control transfer, a whole block directly, then hands control back. Now, In the case of my burst mode in AHP protocol and AXA protocol, also we have seen this particular burst mode. So EISA also supports this particular burst mode. So it allows multiple words move per address cycle instead of one, which is far less overhead. And also auto configuration. So each card stores its own configuration data, boot time, software assignments, resources automatically. So what do you mean by booting and what do you mean by configuration of data? And all we are going to discuss anyways in the case in our further sessions. And if I want to brief recap of this particular ISA versus EISA, so it was introduced in 1981. ISA was introduced in 1981, and EISA was introduced in 1980. And the bus width of this ISA architecture is only 8 bits or 16 bits, whereas in the case of my EISA, it is 32 bits. And bus marshalling is not supported by ISA architecture, whereas EISA supports bus marshalling. And burst transfers are not supported by ISA, whereas EISA supports my burst transfer. And configuration, if I want to configure an ISA bus, I should use manual jumpers, whereas EISA supports software auto configuration. You don't need manual jumpers for it. And you can use ISA where you can use for normal desktop PCs, but you can use EISA for servers and high-end workstations. So ISA, it is the original simple 8 or 16-bit expansion, whereas EISA, it is 1988 industry response that extended ISA to 32-bit. And also the main point here it is staying backward compatibility. It was offering backward compatibility. And this two ISA as well as EISA are replaced by PCA. But it is also going to use the ideas which were implemented in EISA as well as ISA, and still those ideas are used for today. That's the reason we need to first of all understand about ISA and EISA. And this is the introduction about what exactly do you mean by ISA and what exactly do you mean by EISA, and what are this particular brief insights. So that's about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.